I think that the most surprising thing to me is that developers think that vector databases and vector search is like a magic bullet. While it's very powerful, it's not a magic bullet. It's not a fit for everything. It's a tool, and happy to discuss more about that.
Hello, and welcome to this amazing episode we have today where we're talking all about vector search, multimodal search, AI agents in OpenSearch, and more. And today I have a friend with me here to talk about this, Dotan Horovitz. He is a senior developer advocate of OpenSearch or of open source at AWS, and he is an OpenSearch ambassador. Dotan, how are you doing?
Great, Brian. Thanks so much for inviting me to your podcast.
Yeah, of course. We're going to just jump right into this. You have a lot of experience with OpenSearch. You go all around the world talking about this. So let's just jump in and help the viewers understand some of the things that they're either maybe don't understand about vectors and AI in the first place, but even more specifically about that and how it relates to OpenSearch.
Sounds good.
So with that, like at a basic level, like level setting here, what are vectors and what is vector search?
So vectors, you can think about it like a series of floating point numbers that represent your search query or your data in a multi-dimensional space. So instead of what we usually, when we do lexical search, and we have the actual text itself, let's say, here we actually have a representation of that in a multi-dimensional space. And the multiple dimensions are the ones that capture the essence of your data in the relevant context, in the relevant semantics.
So you mentioned lexical search. You know, for the viewers that maybe don't understand the differences, that would be more like when you go to eBay and you used to search for something like a specific book. You're looking for a specific title or a specific string that matches the document, or in like Microsoft Word, and you're looking for specific words to match what you're looking for. Whereas vectors, you're just talking about the essence of what they're looking for. So kind of what would be an example of something that could be returned with vector search where lexical search is looking for the exact match?
Yeah, so I don't know if you look for comics books that are about Star Wars, okay, and you put the exact expression Star Wars, you'll find all the results that may be around Star Wars. But if I'm now querying about Darth Vader, knowing that Darth Vader relates to Star Wars or something like that, this is already semantics. This is something that will not get out of just because I'm a Star Wars geek. Just giving this example, but this is sort of the difference between, I guess, the exact phrasing or variant of that. If you search for a cat, it will still find cats, kittens, and things similar. But something in the broader context, I don't know, felines, like or something like that, then we're broadening it into a context that you need the semantic search.
Yeah. So I mentioned that you've gone around the world. You've been presenting at OpenSearchCon in Japan. You've been in Korea recently. You've done a number of things in Israel, and I'm sure a number of virtual things as well. As you're talking with some of these people, what is like the most surprising misconception that you are seeing that developers have about vector search?
I think that the most surprising thing to me is that developers think that vector databases and vector search is like a magic bullet. They're used to working very hard to get and fine tune their search with lexical search and all of that, and they think, oh, we can just dump all of that and replace that with a vector database. We'll throw everything in, and now everything, and just ask in plain language, natural language, and everything will come out on its own. And while it's very powerful, it's not a magic bullet. It's not a fit for everything. It's a tool, and happy to discuss more about that. I'm sure we'll have some more time on this one.
Yeah. I mean, I think a lot of people tend to pivot when a new technology comes out. Everybody wants to jump on board. It's the new thing, it's what's cool. But it sounds like there's kind of a place for vector search, and there's maybe a place where it's not necessarily the best. You know, if there's lexical search and there's vector search, is there a hybrid search, or is there a better way for people to tackle this?
So yes, indeed, there is also a hybrid search, and as I said, these are different tools for different purposes. So it's really, really important to understand what's the essence of each one of them. So lexical search is keyword-based search. So if you search for certain terms, phrases, or the examples we gave before, these are the sorts of things that lexical search is very good at. It's very accurate. But on the other hand, as we said, for vector search is classic for semantics, to understand context, broader context. We talked about Darth Vader and maybe Star Wars, but it could be, I don't know, if I'm looking for aliens and I have a book, The Martian. Will The Martian be caught when you search in a search about aliens? This is semantics that you need to understand. And the hybrid search is something that brings, I guess, the both. I guess the best way to describe it is maybe to ground the semantics with certain factual things that where you don't want any interpretation. When I state Coca-Cola, I want exactly Coca-Cola and not other types of drinks that are semantically related. Or when I have a certain part number, or when I have a certain order ID, or price range, these are very precise things that here. Please give me the lexical sense of these things. This is, I know what I want here. So when you have hybrid search, you can actually have these groundings, these anchors in your query.
Okay. So almost like bumpers in a bowling alley to just kind of keep search within a certain parameter of results, correct?
Yeah, and by the way, we used to do these things for those who've been going way back with lexical search. We did have, so you have in Lucene, for example, you have the match query that is like the full text search, but you could ground it also with terms. When you use the more elaborate queries, compound queries, you could ground them with things that are, as I said, like part number. You wanted this exact part number. You can put the terms queries or range queries on specific numerical values or things like that. So we did some of that. The notion or the flexibility exists to a certain degree also in lexical search, but as I said, semantics takes it way, way broader. So the anchoring becomes much more crucial.
So with semantic search, we're talking about vectors being able to be searched and they're within a multidimensional space here. What is multimodal and how does that fit into semantic search and vectors?
It's a great question and a lot of misconception, or even the phrase, and I guess the English language has something to do with that because multimodal is not multimodal. So modal is in MODAL. This is like talking about the fact that we don't actually need to search with text. We can actually search with other modalities such as images, video, audio, or similar because they also contain valuable information. And when we go to the vector search, this multi-dimensional space, we're not bound now and no longer to text. So, by the way, we can query by text query. Please find me all the fancy slippers for cold winter nights, and then find the results based on images, although the query was text-based. And the beauty is that you can actually not only have multiple modalities, you can even have multimodal search just to make things more interesting. Whereas I can put on the same multi-dimensional space both um, documents that are text-based and both documents that are video and audio and others, maybe even documents that are themselves multimodal. If you look at the common PDF, for example, you have the headers, you have the paragraphs, you have maybe a chart, maybe you have a table. Each one of these is a different modality that I want to use a different machine learning model to then translate to transform. The right term is to transform into a vector or an embedding, a vector embedding, and it's still part of the same document. So this is the richness that we get when we switch over to the vector search domain.
Yeah, and I think this part is so cool. And I think a lot of people miss this step when we talk about vectors. We talk about the different types of content that can be a vector. I think there's a big gap that people miss of like how it gets from the piece of content to a group of numbers or that vector. And you touched on it there briefly of this machine learning. So first off, you need a model to be able to interpret the data and give you a vector. But I think the second piece of this is does there need to be consistency in the model that you use to make sure that vectors are within the same area, or can you use different models at the same time for different objects or documents and have consistency in their vector spacings?
So you need to use, you typically use the same model across the documents, because then maybe you can talk about how afterwards the search is being done, but the search uses algorithms to calculate proximity, like find the closest, it's called KNN, K nearest neighbors, so the closest vectors. And in order to do that, the notion of proximity assumes that all of them were generated based off of the same model. Otherwise, it's very, very difficult to then put them on the same scale, if you will, and do all these algorithms to calculate. So you use it, but as I said, you choose the right model, and the model itself could be multimodal model. So if you know that you're going to index documents, some of which are images, let's say, and some of them are text, and you use a multimodal model that can support both image and text, then the model will successfully generate embeddings for both types of modalities, and then you can run the searches on them.
So if we were to break this down visually for our viewers here, if I said if I was embedding different maybe items from Amazon into a database here, and I maybe do red boots, that may end up with a vector over here, and rain boots maybe is in a similar spot where running shoes is further away over here, right? Um, and then hiking shoes are probably somewhere else outside of that. But because we're using the same model to create these vectors, it's able to place them into certain localities to give that reference. And then when someone searches, that KNN or the K nearest neighbor is basically looking at a radius around a specific object and seeing what all shows up within that radius. Is that an accurate depiction?
So in broad strokes, yes, but I think since your audience I know is technical, maybe we can dive a bit deeper into this point, because there's again, those who come from maybe lexical search know BM25 is a popular algorithm that you use to calculate similar documents, the relevancies, rank the relevancy. In vector space, it's a bit more of a complex notion. First, even before the algorithm, you even need to you start by the basics of even what's the distance, how you calculate the distance, because nearest neighbors, what is a near neighbor, what constitutes near, and how do you calculate the distance? And as basic as this question may sound, there are different ways, mathematical ways to calculate distances. This is called in OpenSearch, it's called spaces, and in others as well. So first of all, you even define your space and and different spaces have different qualities depending on your. I'm not going to the math. This is usually your data scientists are the ones who tackle this, the setup. So this is based on the nature of your data, the nature of your searches. This is the determination of the space, and then comes the algorithm that you mentioned. And even here we say K nearest neighbors. Many people hear this term, this buzz, KNN, but KNN itself is not one. Maybe the precise KNN, the exact KNN, is one algorithm. This is the brute force algorithm, if you will, that runs exhaustive search of all the embeddings you have in your database or in your space, and finding the K nearest neighbors per your definition, how many result you want in your result set. But of course, being a brute force one, it's very intense, it's very time consuming, resource consuming. And when you talk about large data sets and high dimensionality, high cardinality, that becomes really not really plausible. So then you have the approximate KNN or ANN, sometimes it's called, where you have different algorithms that trade off some of this accuracy for a better performance. And here again, you have a choice of multiple algorithms, many of which are open source, by the way. FICE is very famous by Facebook. Lucene has its own. Also, those who know Lucene from the Lexical know that it also supports the semantic search, the vectors, embeddings. So you can choose the engine, you can choose the algorithm, and then you can choose then the engines like sorry, Lucene and Phi is the examples for again the engines themselves, that you can actually uh, again different trade-offs and what would be the right thing for you. So algorithms, sorry, I said engines, but algorithm being like AGNSW, IVF being the ways that you will calculate the k-nearest neighbors, and different engines that will then execute that depending on your scale and your again requirements, pre-filtering, post-filtering, and so on.
So you mentioned like retrieval here and bringing this back, and I think something that everybody here that is listening has had experience with at least once is working with AI and having it hallucinate, where you ask it a question and it comes back so confidently about something that doesn't exist. How do we handle and mitigate these hallucinations within search, whether it's within OpenSearch or just kind of in general with the guardrails that we would set in place?
Yeah. So first of all, yeah, it is a pain, and some of the things we mentioned before, like anchoring the hybrid search, that by the way is supported by OpenSearch. Not if you look at, I know that the topic of this uh, podcast episode is about vector search, but you'll be surprised that many vector searches are strictly vector. So all the things that we talked about, embeddings and KNN and so on, but they don't have this complementary piece of lexical and running both as in a hybrid search mode. So if this is something that's important for you, and I can tell you, and I see that day in and day out, that people, as I said in the beginning, think that vector search is the silver bullet that everything fits. Many of them I see end up with some sort of a hybrid search model because of the relevancy element and the accuracy of the responses and so on. So and so the hybrid search, having these lexical elements to ground the search results, is something very good. Um, and secondly, I think something that's very popular is RAG, retrieval augmented generation. That's very popular, and it grounds your ML model of choice with a knowledge base that you provide, which is up to date, that's is vetted as reliable for you. And by the way, sometimes it's also confidential data of your organization that the ML model could not have had access to. So we couldn't have even expected it to know and to be trained on that one. So if you have your own private proprietary customer information, business information, and so on, you can make sure that this becomes the knowledge base. And I'm glad to say that OpenSearch in that regard is a popular choice for providing this the R, I got the R of the RAG, the retrieval piece of the RAG, so you can actually use OpenSearch for that regard.
So that brings up a really good question. I know VMware, Broadcom, I guess at this point, talked a lot about private AI and running things in your own data centers or for confidential reasons. And you bring this up here where maybe customers don't want or they don't want public AI models to have access to their proprietary confidential information. What if I want to run my own AI agents? And I guess it's a two-piece question here. Can customers run their own private AI agents with OpenSearch? And also, does RAG kind of fit in here when running your own AI agent? It's only trained up until the date that you've finished training it, right? And so what happens to context or knowledge base articles or support tickets that come in after that? Between those two, is it possible for a company to basically run everything privately with their OpenSearch deployment?
So that's a big question that has lots of angles. So I would say first, before even talking about agents, which is a whole different topic on its own, you can bring your own custom model, and you see that companies that have data science teams within their company, it's fine that you say, okay, I need to train my own ML model and I need to work with that. And again, going back to OpenSearch definitely you can install, deploy your custom ML model and serve from your custom ML models. By the way, it has also some pre-trained models, so it's very easy for at least POCing some concepts if you are in the early stages. But definitely, I'd recommend going down the path of either like a specialized LLM or your own custom models. So that's about serving your own, and then your local. You have your own designated inference nodes, preferably, by the way, although you can run them on your worker nodes. the best practice for production, of course, is to have separate inference nodes. And do all of that. So that's on serving custom models and running private. Now, if we talk about agents, that's again a very very large scope. So first of all, if you want to run your own agent, you can do that, and I'm glad to say that OpenSearch has a very elaborate agentic framework. It has multiple built-in agent types. Actually, published very recently a whole blog post about that. So I don't know if you have show notes. I can I can give you the link to put in the show notes. So you have from running simple sequential flows all the way to complex plan, execute, reflect flows, React, what's called React, and multi-agent flows as well. So you have one agent, let's say, that does the planning, that is good at that and specializes in that, and then you have different agents that take care of different aspects of the execution, each one with its own specialty. By the way, very similar to how we human would might have done that. Like, maybe an architect that has the architecture, and then the different front end and a back end engineer or whatnot. So you can think about it. It's very, you want this specialty, and the multi-agent is a great way to do that. And I'm glad to say, by the way, that version 3, like the major release of version 3, has been a leap in terms of the agentic framework. So a lot of these actually came out just in the past 6-7 months within version 3. Um, and the portfolio of agent is really rich. It's suitable for various tasks. It could be you mentioned RAG, retrieval augmented generation, but it could be also chatbots and research and automated RCA, root cause analysis, and whatnot. So really a nice framework, and that's only the piece that is if you run it yourself, like embedded within OpenSearch. Now, many have these agents running on a separate framework, which is fine. And then the question is, so can I still access OpenSearch from my agent? Can I do that? And I'm glad to say that this is also supported. So OpenSearch, again, on version 3, introduced native MCP support, so Model Context Protocol. That's like today's de facto for this communication. Actually, just a couple of weeks ago, back in during Open Source Summit Japan, when I was there was an announcement of the AAIF, the Agentic AI Foundation, that is under the CNCF, and MCP is a central piece of the new AAIF foundation. So you have your built-in MCP server that exposes operations from OpenSearch, such as searching indexes, pulling index stats, and so on. It exposes that as tools that the agents can then invoke. So you have, and then I don't know whether you run Anthropic, LangChain, OpenAI, whatnot. You can still you can consume these and query your data that is in OpenSearch via standard protocol.
Yeah, fantastic. I know we're coming to a close here. Before I ask a few more questions, is there anything that I didn't touch on that you think is important that we should share with our viewers?
Well, I think, first of all, it's important to say this is a foundation-led open source, which means that the power of the project is the power of the people contributing to it. So every stage that I'm at, I use the opportunity to call out to the folks that are passionate about the topic, that are engaged, that find it a useful piece of the architecture, to get involved as well. You can actually impact the roadmap. You can and if there's things that don't work the way you expect them to work, this is the beauty of open source. So really looking forward to seeing you. And there's so much to do in so many angles. We mentioned that just on this chat about the vector engine and the agentic, and we haven't even touched the UI aspects and search relevancy workbench, and so many other angles that everyone and anyone can find a place where they can make an impact.
Fantastic. All right, real quick, few last questions here. Is there one feature you wish more teams used in OpenSearch for AI?
So we haven't had the chance to delve into that, but I do want to just mention that OpenSearch also supports neural sparse search. So that's sort of a sweet spot between I guess the lexical and the semantic, because embeddings could be heavy on memory consumption and processing and so on. So actually, neural sparse search can offer some middle ground that you can still use machine learning to get context for your queries, but still then afterwards run the standard BM25, the lexical search on the results after you get this extra, let's say, ranking on the different tokens that give the context. So just if this is something that is of interest to you, search neural sparse search. That's a cool new thing that I expect to gain a lot of momentum.
Awesome. You talked about not throwing everything into vector search or semantic search. You didn't really dive into this too much, but like, what's a PSA here for vector indexing? What's something you want people to know? Like, don't do this.
I think the biggest thing is the same thing that I also say on Lexical. Think what you search on, and things that are heavy and you actually don't use them to search, you can just put them on a separate storage and fetch them once you have the result set and you need to, I don't know, do something with it to generate some, I don't know, web page or whatnot. Get it from there. You have a video attached to it, but you don't actually search the video itself. There's no room to index that and pull that. So think about what you actually is the searchable element of your data and do that. And it's very, very fine to have other storage for types for your full data or related data or extra that you then fetch from when you have the right result set for you to do the downstream stuff.
I feel like there's a whole episode that we could dive into on that single topic.
Sure.
All right, two more here. What is, in your opinion, the best resource to learn hybrid search the right way?
So I'm biased, but I think we have great material with the OpenSearch community, both on the written stuff, but also very, very good talks that we've had at OpenSearchCon. OpenSearchCon, by the way, is the regional event that we have for the OpenSearch project under the Linux Foundation in different regions. So we have in North America, in Europe, in India. As I mentioned, you mentioned, we had the first ones in Japan and Korea recently. We're going to have the China one early 2026. So great talks, but by practitioners, by contributors, by maintainers, by search experts. So I highly recommend checking those resources.
Awesome. And last question, if people want to learn more about you, where can they find you?
So I'm everywhere. My surname is my handle everywhere. So if you search Horovitz, Horovitz on Twitter, X, on LinkedIn, on Blue Sky, on Mastodon, on YouTube, on Medium, you'll find me. And of course, on OpenSearch Slack, you'll find me. I'm also CNCF ambassador, and you'll find me on the CNCF Slack. So I don't know which communities you hang out in, but I'm there. And if you are interested in OpenSearch, it's a call out also to join us on Slack, because this is the place where we chat about everything. So it's and open for everyone to join. So check it out, and yeah, feel free to reach out to me. Happy to get to know more members of the community.
I'll throw your handle in the show notes and stuff as well.
Great.
So, hey, Dotan, thank you so much for joining me today. I think this was actually full of so much good information. I think it's going to help our viewers out a lot. And hopefully we can get you on another episode in the future to deep dive into some more of these topics. So thank you so much.
Thanks, Brian. Thanks for having me.